Hey, what's up guys, my name is Cherno and welcome to episode 16 of the Serialization series. This is the final episode. This is it. The last episode, the season finale of the Serialization series. So today we're going to wrap up the series and we're going to basically aim to do two things. The first thing is going to be to clean up the API and clean up the code that we have and see if there's anything we can do to just make it a bit better, right? And we're also going to see if there are any other methods we would like to expose, or maybe other kind of utility and other sorts of methods that we can create to make our lives easier when using the API, right? And then we're going to jump into an example and see how we can actually use this library here to serialize something in kind of a real world setting, right? So we'll create like a little dummy game here. It won't really be a game or anything, but we'll create like the skeleton for some kind of game, see if we can serialize that out. And I'm sure along the way we might find things that things that we can do to our API to make it a bit easier to achieve certain things. So that's kind of the idea. We'll do all that stuff. So we'll start off with the API. The things that I wanted to address first of all were these things, right? So we've got the container types, we've got the types. They look pretty good to me. I don't think there's anything we need to do with them. But if we go into like Serialization writer, for example, someone actually pointed out in a comment that obviously this isn't really a writer anymore. It does a lot more than just write stuff, right? It actually writes, are we even writing the header in the version? I just realized, I don't think we are. Oh, we've got the header here. That's fantastic, first of all. But anyway, we should be writing the header in the version. So see, this is what I mean. Let's go through this and see if we can kind of clean it up. So we've got the, we'll delete that stuff. We're not using that anywhere anyway, but I will add a version, right? This will just be a short, 2 bytes should be enough, right? We could do like a full kind of major minor version thing. I don't really think that's necessary, especially for this scenario. The only thing that you have to do to make this work right now is go into your serialize or your get bytes method and just make sure that we are in fact writing out that version. And then I'm also going to make sure that in the reading side of things, I'm also going to read that version. And again, we're going to do a similar thing where we just basically do read short. And make sure that that kind of short that we read here is actually equal to version, right? Just to make sure that we're on the right kind of thing. In fact, I might even not really bring this out as an assertion, but say that if this doesn't equal version, then we basically should return null and say something like invalid version, right? In fact, I might just put in something really quick here, invalid RCDB version. And then we'll return null, okay? Then otherwise, I mean, we'll make sure that we, of course, advance our pointer by the size of a short, which is 2 bytes. And we kind of go on. Let's just quickly run that again. We actually managed to get ourselves into a crash somehow. Oh, we need to add that to the size, of course. So there are a few things we need to do here and there. So header.length +2 +1. So now, okay, now we're good. We get the same result as before. Okay, this is why we have like these tests. They're almost like unit tests, right? I didn't set up real unit tests here just because that would have taken a bunch of extra time. But definitely setting up unit tests in this scenario would be a fantastic idea because there are a lot of things that you kind of need to watch for whenever you change the structure of this stuff. And even having like non-official unit tests, which is kind of what this is also a pretty good idea. Okay, anyway. Yeah, so this is more or less like serialization utils, I'll call it. Okay, I'm just going to refactor that. I hit Alt-Shift-R there, or if you right-click here, go to refactor, then rename. You will be able to rename that class. It doesn't really matter because we are using it statically everywhere, so it's not a big deal. But we could do something like this, and we now have all of our kind of utility methods right on in here. Cool. So anyway, I forgot to say that I think we had a problem with this stuff, and we had to get this as an int. What was that all about? Because I remember there was something wrong with that. that required us to do this stuff. Oh yeah, there was the whole issue of the byte being negative. I think that this should probably be replaced anyway. So if we just wrap this as a 2 and then I say get char, we'll just kind of do this everywhere. And just make sure that we're good. Read booleans. So was this if it was like packed, I guess? Oh, this was a boolean array, of course. These are the arrays. Okay, so we'll delete that. Read long again will just become this. Make sure we have 8 bytes here. And then, yeah, like this stuff is pretty good. We can just convert the int bits and stuff to float. I hope that this will kind of carry across well. I'm sure it will. Anyway, there we have it. That looks pretty good to me. Just cleaning up some stuff here and there. Now, the big thing that I wanted to clean up was the fact that RC object and RC field and all this stuff, they all have the same kind of, well, they all have names, for example, and they all kind of have the same set name, get name kind of methods, and it's just kind of getting a little bit annoying having to deal with all that. So I'm going to make a new class called RC base, right? And then RC base is going to be kind of the base class. It's going to be, I'm not sure if I'll make it an abstract class, but basically I'm just going to make it so that all this stuff kind of extends from this base class. So field and object and string, right? And then I will move this get name, set name all the way to base. So where's base? Here, right? And then of course I'll also move stuff like the, where did I just move that from? So this can now get deleted. I'll also move stuff like name and the name length out of here. All of this stuff is going to have a name anyway, just like that. Okay. This should probably be private, I imagine. I don't think we'll be getting that too often. In fact, we probably wouldn't be getting this at all, I imagine. And then for the size as well is something that we'll have to carry across. So the way that we're going to do size is going to be a bit different because I imagine, as you can imagine, size is something that is kind of delicate. So basically, like the size is going to contain just the name here, and all of this kind of 1 plus 2 plus whatever, that's not really going to stay the same. We're going to set the size to 2, meaning that it does indeed carry name length, okay? And then when we go out of that, we'll have to calculate everything kind of again. So if we go back to RC object and we have this size here, right? I'm going to copy this real quick. I'm going to kind of recalculate it here real quick. So we have the container type. We have the name, and that's kind of moved out of this class now. So we only care about stuff that's in this class. And the size, of course, is 4 bytes here. And then we have field count, string count, and all that stuff. So this size is pretty accurate, okay? So all we're going to do is we're going to cut that and put it into the constructor, and that is all we have to do, okay? And then the size, of course, will be set correctly. We probably want to also move this into the other constructor, I imagine. Let me just see what we got here. Yeah, so I guess new RC object is how we really create stuff. So we'll set the size there. I don't think this size actually needs to get set because it will. This is the deserialized version, so we'll kind of leave it like that. But that is kind of, and this should be plus equals, right? And then this is going to kind of just append all the extra stuff we have here to the base size, which is only the size for this base class, right? Size, the actual size variable should be here as well. So it should really be 2 plus 4 because we've got 2 bytes for the short and 4 bytes for the int. So back out here, we can get rid of that int. And there we have it, okay? So this should be, this size should be exactly the amount of fields we have here. Okay, now this size offset thing was just a test that we used, I think, and it's not actually used anywhere, so we can remove that for now, especially because us moving the size around like that does somewhat invalidate it. Okay, cool. So when we write out this stuff, this should all be protected, of course. We shouldn't really have any problems with any of that. Good. Let's move on to RC array. So RC array will also extend RC base. We'll delete that. we'll move the size into the constructor, which was going to have to be here in this case. We change this to plus equals. We've got container type. We've got the type, which is a byte as well. We've got the count, which is an int. And then we've got a bunch of other stuff. So let's see. So is this all we have? I felt like we had more. 1 plus 1 plus 4, right? 1 plus 1 plus 4. I think that's actually it. Let's take a look at what we actually wrote out. So 1, that's taken care of, plus 1 plus, yeah, okay, cool. So 1 plus 1 plus 4. Set name, get name can get removed, of course, which is the whole point of this thing. And that is looking pretty good to me. Okay, so RC field is next. Doesn't even have a size. Oh, this is field, right? So I guess the size doesn't really get written out at all here. Okay, but obviously name length and name can still get removed, as can get name and set name. And then I think we're good. Okay, cool. Yes. Yeah, so there we go. That's fine. And then what else do we have? RC string. So we can get rid of name length and name. Okay, this does have a size. So let's move that into the only constructor that we have. So size is going to be plus equals 1 for the container type, 4 for the count, and that looks like that's it. So we went from having 2 plus 4, which was the count of, the name length and the size, to just getting rid of them, obviously, because we only really have those two in here. Okay, cool. Is that it? I think that might be it. Does this have a get name and set name? It's got a get string, which is different. Nothing to do with name. I guess we moved it out of this class already. Cool. I think that's it. Okay, let's just take it out for a spin. See what we get. Okay, crashes. That's expected. Looks like we wrote out the size wrong or something like that. I'm not 100% sure. I just really want to make sure that we're not actually constructing that here or anything like that, because we might be, and that would result in a problem. So this is a problem when we're actually serializing data. That's interesting. So maybe database get size just returned the wrong size. Where do we set the size here? Oh, we don't. Okay, yeah, that's important. So why did I not name length and name? Oh, we didn't do it for database. That's important. It's kind of the most important thing. Okay, so let's grab the size, and let's set this to the public version. So size plus equals header length, 2 for the version. Then we have 1 for the container type. Then we need 4. We don't need the size, of course, so just 2. So again, we get rid of 2 plus 4 there. Let's run that again. Okay, still array index out of bounds. Destination, I'm guessing we didn't allocate enough space is probably what's happened. Yeah, I assume so. Okay. Database get size does return size. We are doing plus equals. How do we create the database? Let me just check that. Okay, just by new database. So it is using this constructor. Cool. Set name, we'll just append the name length to the size, which is 2 plus 4. Okay, that's correct. And then we have. So hang on a minute. Write bytes, and that is a short value. This failed? How is that even possible? We're an RC object. Oh, okay. So okay, that makes more sense. Yeah, so I don't know what went wrong here, but definitely excited to find out. All right, so after a bit of digging, it was a very, very subtle mistake on my part. When I set the size in RC string, I assigned it to 1 plus 4 instead of adding 1 plus 4 to it. Because of course, if we just assign it, then we overwrite the extra 6 bytes we have for the name length and the size. So very, very delicate operation, of course. But if we run that now, it should be the same as before. Okay. So cool. Let's add back all of our things and serialize the whole thing. See how that works. Looks pretty good to me. Okay, great. So there we have it. We did quite a bit of cleanup there. We made this RC base class that contained basically, I think, everything that we really kind of share in common in terms of the name at least. And then of course the size, whilst that isn't used, the size that we have in RC base is used by everything except for field, and that's fine because you can see field has its own kind of get size thing that just returns that. We could like spend some other time, like we could do some other things such as maybe make this an abstract class and then do something like public int get size or public abstract int get size. Just making sure that everything has a get size, but you know, I mean, there's really no point to do that. Like, I'll leave it in here because I've already done it, but there's really not much point to that because I don't think that we'll be referring to these things as like RC base or something. Very, you know, like when we make a database or something, I don't think we'll be doing something like that ever really, right? Because that's just a little bit weird. Like we'll always be referring to these as, you know, a database or an object or a field or whatever. So there we have it. That's a bit of cleanup there. I don't think I want anything else from the API side. So let's kind of get rid of this and see if we can create a cool little scenario in which we serialize and deserialize things. So I'll literally get rid of, I don't want to really get rid of it. I think I'll just make a new class inside our test here called sandbox. And then, so this will be kind of a little sandbox for us. So this is our standard serialization, deserialization test. And then we'll have a new sandbox. And then we'll have something fun like sandbox.play, so we can play in the sandbox. Why not? Okay, cool. So we'll have a class in here called entity. I think that's usually a good way to go. And we might have a class called like player or something. So I'm kind of trying to think up of a cool little real life kind of experience that we can kind of play around with. So if we have an entity in a player class, you know, the stuff that the entity might have like private int xy, a name, maybe like we'll also have a level class. So we might have like these kind of details and something like, I don't know, man. We might have something like, what else does an entity have? I should open up the game programming series and see, but I think that's mainly the important stuff. Like we probably don't even have names, but we do have other things like whether or not it's removed, for example, which we don't really care about because if the entity, like if we had a boolean called removed, like we do, for example, in the game programming series, it doesn't really matter because we definitely won't be serializing stuff that has been removed. Because they'll actually be deleted from the level anyway, the next update. So player might have some additional things like, I don't even know. I hate coming up with this stuff on the spot, but player might have some additional things such as, oh, well, you know, level will have, entity will have a level as well. And probably an init, public void init, which will kind of do the same thing as it did there. This dot level equals level. Player might have player might have a name and entities might not. It might have like a sprite or something. I don't know. Private string avatar path, which might be like, I don't know, something. And then when we construct a player, you know, we might want to make a player at a certain location, into X and Y. We might set the name to like name. So we'll say this dot name equals name and put that in here. Just make this stuff protected real quick. This dot name equals name. Okay, this dot x equals x, and we've got all that stuff. We'll of course make sure that this actually extends entity. Avatar path might be something like res avatar.png. I don't know, I'm just guessing at this point. And this is kind of the way that it'll all get set up. And then level, of course, we'll have like a list of entities. It might have like a add method. It might have, you know, our standard kind of update, render, whatever. I'm just adding some stuff here so it looks more legit. Level might have, sorry, a width and a height. File path, something like that. So that when we like make a level, you know, we give it the path. We might even give it something like, I'll just say path. We might even, well, like, you know, in a real scenario, we'd probably like read the width and height from the level file, but in this case, we'll just put in some fake values. So anyway, we've got this kind of situation here. I think that's pretty good. In our sandbox or in play or something, we might make an entity like a mob, which would just, I guess, entity doesn't really have a constructor, but so this will also do e.init this. We'll also have something like maybe an entity constructor which just sets x to 0, y to 0. They should already be 0 anyway. But we'll just have like a constructor there for fun. So we'll have like a mob, for example. We might have a player. Cherno at, let's just say 40, 28. And then let's just say we make a new level, level.lvl or something. Level.add mob, level.add player. Okay, cool. So I think that's decent. I think that's what we've pretty much got here anyway. So let's just say that we want to serialize the level. So we say level.save res, or I'll just call it level.raincloud database. Okay, so how do we serialize all this data that we have here? Okay, how do we save out that level? Well, glad you asked. So the way that we'll do it is, well, let's see how we'll do it. I'm not 100% sure yet. So I guess we'll have our path, right? Remember, this is supposed to be as simple as possible. If I refer back to our tests, it looks like we just managed to do something like, okay, so we had a save to file. So this save to file stuff could probably be moved into the actual database, I imagine. So RC database, it has deserialized from file. We'll have serialize to file. I guess this will just be lowercase. It won't be static either. And it'll just have a path. And then what we'll do is we'll write the data that we write here. We'll probably have to create that. So we'll say byte data equals new byte get size. And then we'll say something like get bytes, destination being data, pointer being 0. And then we'll write data out. Okay, so that's pretty simple. Serialize to file should work pretty well for us. So if we go back to main and we can adjust what we've got here. So instead of save to file or anything and having to create this stream or whatever, we should just be able to say database.serialize to file test.rcd. Okay, so let's say we went with RCD instead of RCDB. But anyway, yeah, so that'll be easy to do. We don't have to do anything in terms of actual file writing ourselves. We'll kind of let the database take care of that. So back out here, so RCD, if we just level.save that, ideally what we probably want to do is serialize everything. So in the save method, here's what we'll do. We'll make a database. Let's also give this a name. So in this case, we'll just say something like level 1. So we'll say our RC database equals new RC database. We might call this like level or something. Level save, level data. we'll also, so here's what we'll do. We'll create an object. The other thing that I think I forgot to mention was that I don't think objects can have other objects in them right now. So that's something that you might want to add. Again, totally up to you. But we'll probably do something like we'll have all the level data in the again, it totally doesn't matter. It just depends how you see the data. If you kind of see it as a tree of objects, then it's totally fine to make it so that databases are nested inside databases. If you just see it as like a flat list, like as just a flat array rather than a tree, then you don't need that nesting ability. So it's not really a matter of what's possible or whatnot. Anything that you do with a tree is going to be possible with a flat list. It's just that trees, of course, are a much better data structure if you want to go to a specific leaf and you know the path to get to that leaf, right? Whereas if you look at level, what we've really got is a flat list anyway. So in this case, having objects inside objects probably isn't the best idea. So we'll have level data. I might actually have the database as the level. So I might actually just say name, okay? And then what I'm really going to do is I'm going to go through every single entity we have here in our entities list. And I'm going to say, I'm going to create an object out of it. So RC object entity equals new RC object string name. Now this is where it gets interesting. We could use the entity's name. Entities don't necessarily have names though. So instead, you really could call this anything you want. Like I could, for example, call this entity plus and then the index of the array. I might actually do that. So we'll say int I equals 0, I is less than entities dot size I plus plus, and I'll say we'll create a new object. The actual entity is going to be entities.getI. It doesn't really matter because remember, the reason I keep saying it doesn't really matter is because this is literally just the reverse of when we actually load it. You just need to know, you just need to choose a way to save it so that you know how to load it. So we'll say something like E plus I, right? So we have that entity. And I guess the fact that we have a number here as well probably also tells us which array index it is. Of course, we could also say like entity dot add field RC field dot, so let's say what we like an integer, for example, that just has the name being the array index and then the value being I. So we could also store that if you don't want to have to pass this string or something. But anyway, other than that, we'll probably say something like, rather than having to create something like this every single time, we'll probably more or less say something like RC object entity equals E dot serialize, E dot serialize, right? And then this stuff, we can kind of say, you know what? This stuff is going to be moved into, so serialize into entity, right? So again, here we could either say that this is actually something that returns an RC object, but it's usually better because of course the entities lists in the level, they need the context of the level. So I like actually writing this as a void and then having it take in an RC object. So kind of like what I did in the other thing, right? And then all this will do is it'll kind of add everything to it. So we might have an override in player that adds these extra fields. But anyway, the reason this works so well is because it means that I can just, over here, I can just say, I want to serialize, I can still have my new RC object. I know which index it is in the array, so I can have something like that. Okay, when I serialize it, I just need to pass an entity. And then of course I can add extra things such as, you know, these fields, for example. So I might add that in first. And then over here, the reason it works so well is because when I write stuff like object.add field, RC field dot integer, so we have X, we have Y, we have, I guess we'll add that boolean just for lols, but we don't really need it. So boolean removed. And then we don't really need to serialize the level, of course. The reason this works so well is because when I do, since we're not returning a new object, when I do something like this, it's very easy to just say that actually we're going to run super.serialize object, right? And then we'll just add on the stuff that we were missing. And you could do that like before or after, up to you. So for example, I guess I'll do it after, but we'll add in the name of the avatar and the avatar path. So we'll say object.add field, or that's actually more of a string. These are strings. So add string, rc string dot create. So name will be name, data will be data, or name rather. And then we'll do the same thing for the avatar path. Okay, so we've serialized that data out, and that's all good now, right? When we run that serialize, it'll just run the super and serialize the base stuff like X, Y, and removed, and also all the other stuff as well. And then what we have here is basically now a collection of entities that have all the data that we want, okay? So if we actually do, at the end of this, when we've kind of run all this stuff and it's all worked out great, we can just say database.serialized file and path. Okay, and that's all we have to do. So you will have to add serialized methods. Of course, we're not using reflection or anything like that, so we don't know the fields. So it's generally you will have to manually serialize each field like this. That's pretty normal though. Like reflection is not the greatest thing in the world either, especially in terms of performance. It definitely makes your life easier and will probably lead to less mistakes, but this is like the old-fashioned way of doing things, and it definitely works very well. So just make sure that you don't forget things. The other thing is, I guess we'll serialize this level stuff as well. So I might add an RC object at the beginning. RC object dot, oh, I think it's just new RC object, right? So level data, for example. And then we might say something like object, I didn't add these to the database either, did I? Make sure you do database dot add object entity. Okay, so we might do something like object dot add field, rc field dot, I guess we'll do the two integers, which is width and height of the level. Again, these aren't things that you would typically serialize because the actual level will be loaded from its own level file. Only the dynamic things would have to be kind of appended here. But I guess we'll do the name of the path as well. So object.addString rc string.create. So we have the name. We have the path. Again, it's just an example. We'll add that object to the database. Okay, cool. So there we have it. That looks pretty good to me. I think that's it. So let's try running this. So I'll comment out this. I'll just do sandbox play. Let's run that. Okay, we didn't get a crash. That's step one. That's good. Let me just quickly bring up the actual serialization thing. I have no idea where that is though. Here it is. Found it. All good. So here it is. We got level.rcd. So we'll quickly open that in hxd. Okay, so what do we have? We've got rcdb, we've got the version number, we've got basically, you can see level 1, and then we've got level data, width, height, name, there's the name, level 1. We've got the path, which is just level, I'll say whatever. I don't even know what we set the path to be. I think level, right? Or something like that. Path, yeah, okay. So there it is. Fine. Let's see. Then we had the entity 0, entity 1, whatever. We've got the avatar path. I don't really care about this. This stuff is kind of meaningless. If we had some kind of serialization viewer, then that would be totally cool, because then we could maybe make like we'd have like a tool. If this was actually used in the game, we'd probably have some kind of tool that kind of would let you see these things in an actual, kind of GUI that we made, so we can easily see the data, and it would deserialize everything for us. But this looks like it has everything we want anyway. So let's do the reverse of that now. Let's actually load, hopefully, everything here based on what we have here, okay? So this kind of relies on us knowing what we want to do as well. Right, as I said, this isn't really, like, we need to know that the first object is a level object, like as in the first object is a level data object, which has everything in it. We could obviously not write these out in the right order, and we could just do something like, hey, database, get me the object that's called level data. But the fact of the matter is, we need to know that there is an object called level data and that it has all these fields that we want. That's just how it works. I think that the biggest thing that we don't have, though, is that actual facility in our API to find objects. So we should definitely have something like public RC object find object string name. And then all this is going to do is go through every single object. Okay, see if the name of the object, so object.name, or rather object.getName, dot equals name. If true, then it'll just return the object, otherwise return null, right? We need a similar thing in terms of our fields as well, and everything else pretty much. So RC object rather should have the stuff that we kind of want here, such as find field by name, right? RC fields, right? And then etc, right? I guess I will add the rest though, because they are kind of important. Find array, find string. I think arrays are last anyway, so find string, will of course return an RC string. The other thing that we could do is obviously this get name is something that appears in every single RC base. So we could just have a generic find RC base and then cast it to what we want. This is just a little bit more robust though, because we don't really know what this is. It's not storing any kind of type. We could obviously move container type from string, since everything has a container type, to RC base, but yeah, I'm not really fond of that idea. Anyway, back into RC object, which is somewhere here. Here it is. We'll just finish this up real quick. So find array, we'll return that array. And there we have it. Okay, so we can kind of find everything now, which is good, because now we don't really need to know anything. We don't really need to know the order in which we serialize anything. But basically, what we'll do is, the other thing that's actually kind of important, by the way, is if we decide on a format such as in our, what am I looking for? Sandbox. In our sandbox, if we decide on something like having E and an index, it's probably also a good idea to quickly just serialize a field here that is the amount of entities that we have. So RC field integer entity count entities.size, right? And if we just do that, it'll make our life kind of looping through everything a lot easier. Cool. So we've got the save. So we'll have a public level load string path. Okay. So RC database equals RC database dot deserialize from file. There's our path. And then basically, so the first thing we're looking for is, of course, that RC object which has our data. So object level data equals database dot find object level data. And then once we've got that, we can begin setting our thing. So level result equals new level. So this is why you always have to have some kind of default constructor. In this case, we'll have a private level constructor here that's just used for recreating stuff from a save game. we'll set result.width equal to level data dot find field. The other thing is, I wonder how we'll get the data from the field. I don't think we've really covered that, have we? We just print out the field. Yeah, that's another thing we need to talk about. But anyway, when we find the field, so width, I believe, is the field, we really need to actually know, because we get the field back, but how can we actually cast it into the right data, right? Like if it's a short, this is us creating everything. Where do we deserialize this? We've deserialized this, so we've got the data here, but we don't actually know what data it is. Like we do know by the type, but that's about it. So there are a few ways you could go about this. It's totally up to you. The best way, I mean, I'm just thinking. You could definitely probably write this as a template, but let's see if we can just do something like public int get int, and then all this will do is it will return read int, byte source being data, and pointer being 0, right? That's the simple way of doing this. So we have to know what type it is, right? We can always check to see what type it is, but apart from that, we can't do much. And the thing is, though, you do need to know what type this is, right? Like the field, the width, whilst you could ask it what type it is, there's no way to just be like, oh, give me an auto type or something like this. I don't know what type it is. You do need to know what type it is. So I think something like get int is totally reasonable. So that's, for example, how we get that. We'll fill this out for the rest of the things really quickly. So get byte, get char, get short, read char. I just want to check real quick that, okay, short comes before char in our chronological ordering here, so I'll quickly reorder that. Short, int is there, good, long, double float boolean is all that remains. Double float boolean. Of course, we have to actually change the return type, obviously. I didn't even think about that. So see, this is great because having a real world usage like this means that we can kind of do this. Also, it means this video is going to be huge, but I did want to pack everything into this one because it is a finale. Okay, there we have it. And that's everything. This will just be return data 0. Okay, so now we can do that. We've got the width and the height. Whoops. Again, you don't really need to look through everything. Like I could be like, hey, hey database, give me your list of fields. Give me your list of objects. I know that the first object is going to be the level data. So thus give me, and I also know the order of the fields because we do know this. I'm just showing you a more kind of universal use case, right? Where we might not know this stuff. So we've got the RC strings that we need to set up. So result dot name, right, equals level data dot find string. The name will be name, I think, right? And then this will just be get string. Then we'll do the same thing for the path. I'm just going to double check. Yep, name and path. Okay, so we have all the level kind of metadata here. The entity count is the last one. Okay, we don't really care about that. As in, that's not something that we store. Entity count. Okay, so now we just have to go through entity count. And, we could, again, one way of doing this would be something like RC object entity equals database.find object with the string e plus I. Totally fine. Not necessarily the worst thing in the world. remember, we do know this though. Like we could obviously just say something like, hey, you know, let's, we know that we have X amount of entities. We know that there's an offset of, you know, 1. So let's say that the offset is like 1 being because the first object is level data. So 1 plus I, and then we could just do something like, hey, you know, fetch me, you know, my entity is just going to really be database dot objects dot get offset. Done. That's my object. No kind of finding and no string concatenation or anything required whatsoever. Totally fine. You have all your data here. That's absolutely acceptable, and that's the way I would probably do it. However, if you don't know what order your database is in for some weird reason, then, or maybe it's a larger database, then this is something that you could do and it will work as well. Probably a little bit slower, or in this case, we definitely won't notice the difference. So when I create my entity, I've got my object. So similarly, how we had that serialize, we just need to have a public static entity deserialize rc object, where we'll just create a new entity. Okay, I guess we do have a constructor here, which is fine. And then we'll just say, you know, like x, for example, is going to equal object dot find field. Again, you could add stuff to your objects like object.getInt immediately, and then it'll just find a field that is an integer with the name that you give it, and then automatically call the .getInt to it, and that would be much better than having to go through this. But, you know, whatevs. So we'll say so find field dot get int, and sorry, this will be result dot x, result dot y, result dot removed. So this is a boolean finally, otherwise it's got a lot of integers everywhere. This is removed. Okay, and then that's all that we really wrote. So we'll just return result. Of course, this will also be the other thing that happens. So this will be a bit more complicated because we don't know if something is a player or not, but it will still be fine. So numerous ways to do this. We could just get the entity first. So we could say entity.deserialize object, which will just get all of the fields that we need, right? And then we could just read them by saying player result equals new player. Quickly make a private constructor here. Okay, so we've got that, and then of course we can set result.x equal to e.x, e.y, e.removed. Okay, and now we've gotten past that, we can set the player specific things. So the player specific things are just the 2 strings really. So result.name is going to be object. I cannot write anything today. Object dot find string name dot get string. Probably should override toString as well. That might be confusing. But anyway, result dot, we can just make like toString or something return return get string. Okay, there we go. So we've got everything. Result is a player, so this should be happy maybe. What? I guess I need to make this static. Yep. Okay, cool. So there we go. That's how we do that. The one thing that we probably should store here as well when we serialize this is what type the entity is. Now in this case, we have no idea what type the entity is, right? So we could say something like, hey, if entity, if E is instance of player, then we'll store something like entity dot, well, we'll always have to store this anyway, but we'll say that int, type equals 0. If e instance of player, type equals 1, and then we'll obviously add in a field. We can just make this a byte that says type and type, okay? Just something like that so that we know what we need to deserialize. What is wrong with you? String byte. Okay, so type is not a byte. There we go. Okay, great. So back here, when we deserialize this stuff, we'll get the find object, and this is what we'll do. The first thing is, we've got that, so we can just check the type real quick. So if entity.get, if entity.find field type .get byte equals 1, then we know that we're dealing with a player. So we'll say entity e equals rc, or rather e equals player dot deserialize entity, else e equals entity dot deserialize, and then at the end we'll just say entities, or result dot entities dot add e. Okay, great. So that should be it. And then at the end we can of course return that. But the point is we now have reconstructed a level from a file. Okay, we should probably test this. So I guess I'll run this again just so it serializes everything. Great. Now we'll do the reverse. So we won't give it anything here. We'll just say level dot deserialize, which isn't a thing because I didn't make it static. It's called load actually. So this needs to be static as well. So level.load, path will be level or res level.level. I don't actually know if the res folder was created. I guess so. Where did it? Nope, it's just there. So we could probably get rid of this. Let's just serialize it one more time, make sure that that's actually good. Okay, so yeah, so we should, but just by this one line here, we should be serializing everything. So if we quickly run this, I'll probably have to put a breakpoint here. If we run this, ooh, that's a that is a bad crash. Oh, the system can't find the file specified. Really? Really, you can't find the file? Refresh. Oh, it's RCD. What did I say it was? Oh, .lvl. Whoops. Oh, because I was fake loading it from... Yeah. Sorry. This was res/level. RCD. Okay, we should probably handle that more gracefully, by the way. That file not found thing. But anyway, level load. Okay, we hit our breakpoint, which is good. So we didn't crash in the deserialization. Let's take a look at our level object. Look at that. So the name is level 1. The width and height is 64128. The path is level.rcd, which I think is wrong. And I know why as well. It's because when we serialize this, the path that we wrote was path and not this dot path. So let's quickly just try that again. So the path should be res level. So let's just stop that real quick and come back here. So this is kind of the first test. I'll just put this around it so that we don't have to create unique variable names. Okay, so level. Let's go into debug, in fact. Level. We have the name being level 1. We have the path as what we set it to, right? We have the width 64, the height 128, and we have two entities, of course. One of them is a player with the avatar path that we have. The name is Cherno. we didn't initialize the entity. That's the only thing we haven't done, which is why this is null, but we have our entity set up here, which is great. So there we go. That's how we can serialize and deserialize stuff. It works really well. As you can see, all we need to do in this case is just call level load, and it'll restore everything from our save file, okay, which is pretty awesome. I didn't check the player's location. That's the last thing I probably should have done. Let's just check that real quick. Or in fact, before we do that, let's quickly say that instead of calling result dot, where do we do this? Instead of calling result.entities.add, of course, we should just do result.add. And that will just add it as if it was, you know, properly added. So now we have entities. We've got 2 entities, of course. We've got one of them is a player. We've actually got the level in there now, which is nice. And then the players, coordinates, X and Y, hopefully 40 and 28, which is what we set them to here. Fantastic. So there we go. That is the end of the serialization series. Hope you guys enjoyed this. If you did, please hit the like button for the final episode in this huge episode, almost an hour long. Yeah, so next time, I guess we'll jump back into game programming. I'll put this on GitHub, by the way. The link will be in the description below if you want to check this out on GitHub. All the code for this entire series will be there. Yeah, if you guys enjoyed the video, please don't forget to hit the like button, and I'll see you guys next time. Goodbye.